So we'll start. Right, as you know, this is our first grade 9 revision class. I did the grade 9 theory class, grade 9 chemistry theory class yesterday. That's from 4 p.m. to 6 p.m. Though it's mentioned as 30. Yeah.
We watched the recordings.
Okay. So there I thought to start the lessons from first unit onwards, but if you are supposed to, if you wish to join with the grade 10 class, I'll be starting from the mid, like acid base indicators and all. Do you have the textbook with you for this Edexcel chemistry?
No.
Yeah, you're having. Okay. So you did local curriculum up to grade 7, isn't it?
Yeah.
Right. So give me 1 minute. Right. Then today I thought to do a small revision on the structure of matter. Structure of matter in the sense atom, the basic structural and functionality of matter. So, what do you know about atom? First of all, I don't know whether you know about me. I think you watched my previous videos, so you should know who am I. My name is Hansani Dilhani. I'm a graduate from College of Chemical Science, and I'm a teacher teaching in a semi-government school, and I was teaching in several international schools in Colombo. Currently, I'm working as an Edexcel chemistry teacher in a school. So, yeah, that's about me. So, now you're in grade 9 and you're doing a Korean curriculum, right? Is it?
Yeah.
Okay. So, what are the subjects there? Do you have science as a combination of all these three, or you are having separate chemistry, biology, and physics, those lessons?
This combined.
It's combined, right? So, okay. And I don't know whether you know the structure of the paper. I mean, do you have an idea about the Edexcel curriculum?
I have seen past papers.
Okay. So usually you are having a one single book. I think you know that thing. And that depends on the type of the school and yeah, basically type of the school and the teacher. Some of the schools start that particular Edexcel O-level book from grade 7 onwards. Some schools they start at 8, grade 8. Uh, grade 8, 9, likewise, usually what I'm doing is I'll take 2 years to complete this one. Then after that, that means if I start the grade 9 textbook this month, I'm targeting the next year 2026 May June exam, right? Uh, September 1, June, yeah. So I don't know whether how the exam is conducted in Korea. Do you have an idea in which month you are going to sit? I mean, whether, yeah, no. Right. You asked, your mother asked about that language thing, no? Whether you can take the Korean language as one. I'll say, check and let you know. And yeah. So basically, this paper consists of several concepts which are like, those are not in the local curriculum. But you know, in local curriculum, you are having a combination of all these biology, physics, and chemistry. But here you are having chemistry as a separate subject, so you have to go for advanced concepts. But those are not that much hard. Anyhow, you have to just polish. I mean, the 1 or 2 steps more than the local curriculum. So if you are familiar with the language and if you are hardworking, yeah, of course, definitely you'll be able to score A for this subject. It's not hard, that much hard, right? It's easy if you work hard, right? Then at the same time, although you don't need to do the practicals for the paper, you have some practical sessions. I mean, practicals or the activities you have to do at school, as you are taking this Edexcel curriculum, as you're sitting this as a private candidate, what you have to do is you should either go through these practicals by yourself, uh, try to do them. I'll help you to do the practicals, because I'm also having some chemicals in here, so I'll demonstrate the practical. If there's any chance or if any facility to have those chemicals and the stuff, then that will be more interesting for you. I think you have two brother and sister, or two sisters? Two sisters, no? I can't see properly. Sorry. It's really, yeah, two sisters. Okay. Uh, right. So yeah, that will be more interesting if you have, if you have the facility to take these and do the practical. There are very, I mean, very simple practicals are there to do, but they'll assess the steps in the practical. What are the practical errors that you come across when you do the particular experiment? So likewise, you better go through this stuff as well. Those are a bit advanced than the local curriculum. Yeah, that's about it. So I thought to start the revision with the structure of atom, as I mentioned. This is a very basic concept, but you're having questions from the those basic concepts in your IGCSE paper. At the same time, I just want you to know, you're having, I think you have the particular textbook. You better download the specification. I don't know whether you have an idea about the specification. Do you have it downloaded? No, there's a specification for IGCSE. uh, you know that it's I can't remember whether I have that one. Actually, in the specification, what you all have is uh, some specification points which are like learning objectives. Once you finish the lesson, you have to go through those learning objectives in the particular topic, under the particular topic, and just check whether you have achieved those objectives. So I'm participating several workshops which are done by the Pearson company itself. So I mean, um, some examiners are visiting us, so we are talking with them. So what I understood is they always ask us to refer that specification, because they prepare the questions from the specification points. So as same as the textbook, you better keep the specification with you and check whether you have done all the specification or the learning objectives at the class, or you have studied them properly. Then you'll be able to score maximum marks, right? Maximum in the sense you will be able to put your maximum effort. Otherwise you'll regret you had this capability but you didn't work hard. So this is really easy. I have to say this is a easy curriculum, because everything is given, not like the other curriculum. There are some, when you take the London O level, there are some other curriculums like Cambridge, this is Edexcel. I feel like this Edexcel is the easiest one in the sense it's more student friendly, right? When you take the textbook, even it's uh, I think it's everything is given in a simple way, easy to remember, easy to memorize. It's not that much complex. The wordings or the whatever the text that they have used, everything is simple, so you'll be able to understand the concepts well. Yeah, that's about the structure of the IGCSE curriculum. So we'll go for the atom, basic structure of the matter, which is atom. Just let me know, what do you know about atom? So this is a very basic concept. From your previous grades onward, you should know what is an atom.
Uh,
Atom?
an atom is the smallest part of an element.
Yeah, smallest part of an element. So,
Um,
okay. Do you
mm,
know anything about subatomic particles?
no.
No. Okay. So yeah, we'll do this.
Oh, wait, no.
Huh?
Is it protons, neutrons,
Yes.
and electrons?
Protons, neutrons, and electrons. Do you have an idea about that? Have you
uh,
studied? Ah, yes. Where
yeah,
did you study?
in the government syllabus.
Uh, in Sri Lanka or in your curriculum?
In Sri Lanka.
Ah, okay. So yeah, of course, you have to study that. I think in grade 7 even you have to study those small concepts, right? Yes. So structure of matter. Under structure of matter, you have to study this atom. So in today's revision class, I'll be talking about the atom, the structure of the atom, the subatomic particles, and second one, mass number. Third one, atomic number. Fourth one, isotopes. In yesterday's lesson, we did different states of matter, right? Uh, but I have some other subtopics to cover there, so I thought to do that one, and then next week definitely I'll do a revision from the state of matter, how to get the physical states according to the temperature, and next week Monday I'll do another part of that lesson. Then after that we will do a revision from those two classes, right? So as this is a very basic concept in chemistry, I thought to do this. Thought to get this topic and revise. You will get some questions at the end of the class. And during the class, I'll give some past paper questions. You can try. Right. So atom. This is the smallest structural unit of matter. Matter means what? Yesterday also I told you. Matter means anything around you, right? You're made out of some atoms. Some atoms, in the sense you are made out of billions or trillions of atoms. When you take a piece of hair of you, it also contains like millions of atoms. So imagine uh, how many number of atoms are involved to build up your own body. Okay, so because of that, so atom is a very important. Knowing about atom is very important when you take chemistry, because in chemistry you are dealing with matter. It may be the liquid, gas, or solid. You have to deal with your talking about the bonding interactions of matter. So matter is made out of atom, right? So atom is the smallest structural functional unit, and atom has three subatomic particles. First we'll take atom. Atom is made out of, it is a basic structural unit. Atom is the basic structural unit of matter, right? Atom is made out of three subatomic particles. What are those three subatomic particles? One is electron. Second, proton. Third, neutron. Electron, proton, and neutron. How they are arranged? Here, when you take an atom, you are having a central core like thing where you have protons and neutrons stick at the middle or center of the atom. And around that, you are having electrons moving in different energy levels. Different energy levels in the sense they have specific amount of energy. At the middle, you are having this nucleus. We call this place or the location as nucleus. Inside the nucleus, you are having protons and neutrons. Protons and neutrons. Electrons are moving around the nucleus. Electrons are moving around the nucleus. Right? How do they move? How do they move around the nucleus? They have specific energy and specific speed, right? So I'll show you this. This is the structure of matter. Atom, this one. Here. You can see. What are the green and red color ones here? Those are protons and neutrons.
Neutron.
Yes, neutrons and protons. I told you when you take an atom, you have nucleus where electrons are moving around the nucleus. Electrons are moving around the nucleus. This is the nucleus where you have neutrons and protons. So in this diagram, you can see protons and neutrons are in green and red color, right? At the same time, electrons are moving around the nucleus. So you can see the first energy level. There are two energy levels in this atom. This is carbon atom. First energy level has 2 electrons. They don't move, they don't jump from one energy level to the other one. There are some instances where they move from one energy level to the other, where if you give energy from an external source, these electrons can jump from the first energy level to the next one. Till then, they have specific path, but still they are moving, right? At the same time, remember, those are not two-dimensional structures. It's like a spherical one. This is actually, atom means something which is like a ball, right? So here, electrons are moving in a spherical path where they have that particular path has a specific energy level, amount of energy. And then the second energy level, you can see 4 electrons are moving, right? So at the center, you are having protons and neutrons. So assume the whole, now what is called the atomic radius or the size of this atom? That means the distance. Atomic radius means the distance between the nucleus and the outermost energy level. The distance between the nucleus and the outermost energy level is considered as this atomic radius. Now assume the diameter, diameter means 2r, no? If this is r, diameter is 2r. So if you take the size of an atom as a stadium, football stadium, and if you place a chickpea on the center of that stadium, the size of the nucleus is equal to the size of that particular chickpea. You know chickpea? What is chickpea? You know, no? Yeah. So the size of the nucleus is that much small. Although you see it like this, the size of the nucleus is very tiny. It's very small when compared to the whole space of the atom. Electrons are moving. They are taking much space to move. But the nucleus, remember, the mass of the whole atom is concentrated on the middle of that particular atom. Why? When you take the mass of those white color electrons, those are negligible. Electrons are having very negligible mass. But when you take the protons and neutrons, they have the whole mass. You have to consider the mass. If you take the relative mass of the proton as 1, the relative mass of the neutron also 1. But the relative mass of electron is negligible. That is 1 over 1840. This amount is negligible. So remember, the whole mass of the atom depends on the mass of that particular small nucleus. The mass of those electrons are negligible. They just have some amount of energy, and those electrons are involved in the reactions. You'll study what are those reactions. Okay, so this is the structure of an atom. Remember, although you see this nucleus as considerably, I mean, the larger part of, they take the larger part of the atom. No, it's not. It's a very tiny one. The whole mass is concentrated or packed in the center of this atom or the nucleus. Remember that thing. So first what you have to do is write the topic atom and write those points. You better draw this structure, or else you can draw this one or this.
Done.
Okay. Now let's compare the differences between these subatomic particles. Now you better draw a table. Let's try the topic comparison of subatomic particles, properties of subatomic particles. Draw a table with 4 columns. Draw a table with 4 columns. Then write properties, protons, neutrons, and electrons.
Done.
So how can you compare those? The property, we'll take the relative charge. Of proton, it's +1, neutron 0, electrons -1. Relative mass, relative mass, it's, if it is 1, neutron also 1, electron 1 upon 1836. And their positions can also be compared. Positions or the locations. Here protons are there in the nucleus. Neutrons, nucleus. Electrons, they are in, they are where? Around
Or
the,
yeah, orbiting.
yeah, orbiting around the nucleus in different energy levels. Basically, they are in energy levels. Electrons orbiting around the nucleus in different energy levels. Quickly complete this table.
Finish.
Right. Then you need to first study about the mass number, atomic number, and about the isotopes. Here, remember, when you take an atom, right, always there's equal number of electrons and protons in an atom. Why? When you take any atom means there's no any charge. If it is an ion, those are having some charges. For an example, we'll take, sodium chloride means what? It's the salt, right? Sodium chloride is a salt. Salt that you eat, salt that you use as a flavoring agent in curries. So that is sodium chloride. So sodium chloride has sodium plus ion and Cl minus ion. But those are now, when you take those species with a charge, we call them as ions. Those, when you take sodium atom, it doesn't contain any charge. Sodium atom mean no charge. But sodium plus mean it is an ion where one electron has been donated to this chloride. You will study how these ionic bonds form in your theory class, right? So when you take atoms, all the time they don't have any charge. So that means if there's no any overall charge, there are two species, there are two subatomic particles with charges. What are those? Protons and electrons. Neutrons doesn't contain any charge, no. Those are neutral. So you don't need to think about the neutrons when you consider the overall charge. So protons give positive charge, electrons give negative charge. So if when you take the whole atom, if there's no any effective charge or overall charge, that means you are having equal number of protons and same number of protons as electrons. Otherwise, you will have an extra charge. Now, assume if you have two protons, there should be two electrons. Otherwise, the atom, it's no more atom, it will be an ion. There's no atoms, right? You have to take now, if you have extra proton, then the electron, that will be a positive ion. If you have extra electron than a proton, then you are having an anion. We call negative ion. Negative ions are known as anions. So, always atoms are having equal number of electrons and protons. But when you take a charged species or ion, there may be different number of electrons or protons. If that ion is a positive charge one, you are having extra protons than electrons. If that ion is a negatively charged one, they are having extra electrons than the protons, right? So remember, always atoms have equal number of protons and electrons. Right? When you take that carbon atom, how many electrons were there? Wait. In this carbon atom, count and tell me how many electrons are there. Two electrons. Electrons are given in which color?
Green. Huh? In green?
No. Electrons are
then white.
It's white there. Then how many electrons are there?
4. Is 2.
As it's moving, I don't know whether you can't count it. You can see this, no? Yeah.
Yeah.
How many white color dots are there? White color dots moving around the nucleus?
4. 5. 4.
3, 4, 5.
6.
Yes, 6 electrons are moving. I know it's difficult to count because it's always moving. In the first energy level, in the first ring, you are having 2 electrons. Second ring, you are having 4 electrons. So ring in the sense, those are the energy levels. You have 2 electrons in the first energy level, another 4 electrons in the second energy level. Can you understand?
Yeah.
So overall, there are 6 electrons moving around this nucleus. So this is the whole carbon atom. Now tell me how many protons should be there in carbon? If you take a carbon atom, how many protons should be there?
2. Yes. 6.
Yes, 6. Why?
It's equal?
Yeah, they should be equal. Very good. Now you should have, now I told you, there should be equal number of electrons and protons. If it is carbon atom, I told you, atom, you are having equal number of electrons and protons, right? So you are having, when you take carbon atom, example, 6 protons and 6 electrons are available in carbon atom. Carbon atom. It should be atom, right? Second one, charged ions contain different number of protons and electrons. Example, positive ions have extra protons. Why? Protons are positive. If you have 3 protons and 2 electrons, the overall charge will be positive, positive 1, right? If there are extra electrons, that means electrons give negative charge, no? So the overall ion will be negative. Positive ions have extra protons, then or more protons than electrons. For an example, we'll write sodium ion, Na+. This is sodium ion. Right? You should write plus sign there. That's why it's an ion. When you take the other one, negative ions have more electrons than protons. That's why they'll get the negative charge. For an example, chloride, Cl-. So, CHLORIDE ions. Okay. Now, can you first write this? Write those stuff. And then I'll give you a question. This is very important. When you take an atom in the sense neutral atom. Neutral means there's no charge. If there's no charge, those are neutral. Then write this.
Finished.
Right. Now I'll give you a past paper question, right? This is your first day in Edexcel, and you are trying to write the answers for the past paper question. Now, are twins or friends?
Yeah, yeah, we're twins.
A twin. So who is the eldest one?
Me,
What's your name?
Mehansa,
Mehansa. Mehansa. Okay. So what was your school in here?
St. Lawrence Convent,
Okay. So where were you? What's your hometown?
Hilianda.
It's very nearby from me.
Mm.
I'm from Horan, Kahatudwa, between Piliyandala and Horan. Okay. Right. Can you say a question in the screen?
Yes,
Right. So this is a past paper. It's easy. Everything is given in the theory. So you just need to pick the answer. First, yeah, draw this table and complete the table first. And then select the answer for the part B. Now you can see question number 2A is a 3-marker question. Okay.
the picture is big, not clear.
Not clear. Okay, wait. Mm. Now, okay.
Yeah,
Why GCSE as the language? Those are the subjects available, right? Arabic, it's first language. First language Arabic. Accounting, Bangla or something, maybe a language. Then biology, Bangladesh studies, business, chemistry, commerce, Chinese is available, computer science, English language. Majority of the students are selecting this English language. Economics, English as a second language, English literature, art and design, French, geography, Greek is there. Global citizenship, German, human biology, history, Islamic, ICT, Islamic studies, ICT, mathematics, Pakistan studies, physics, further pure maths, further pure mathematics, arts and design, photography is there as a subject. It's really nice. Now only I know that. Photography is there as a subject. Then religious studies, Spanish is there, Sinhala also there. Sinhala, science single award, double award. Swahili, I don't know what is it. Maybe it's something like Hindi or whatever. Tamil is there. Yeah, that's it. There's no Korean as language. We'll see again. History also there. Portuguese is there. Not Korean. Russian is there, Turkish is there, Spanish. We'll see whether Korean is available.
Okay, these are finished.
Done.
Yeah.
Proton, what is the relative mass?
One.
1. Electron?
1,836.
Okay, 1,836. Then relative charge of neutron?
0.
0. Electron?
-1.
-1. Position in atom? Protons?
Nucleus.
In nucleus. Electrons?
Electron orbiting for nucleus in different energy nodes.
Yeah. Did you write the answer for the B part? No.
No.
Let's see. No. Yeah, do this one. That means you have scored 3 out of 3 for that question. What is the answer?
D.
Equal number of protons and electrons. Yeah. Then what about the neutron number? There's no specific value. Basically, that depends on the atomic. Now, when you study the mass number, you will see what is neutron number actually, how it varies. Sometimes the neutron number may be less than proton number. sometimes. So you can't get the first one as the answer. You can't say always equal number of protons and neutrons are there. The neutron number can vary. If you have more electrons than proton, that is a negative ion. Okay, so the answer is D. Right. Then this question. Here the table shows the number of electrons, neutrons, and protons in particles P, Q, R, S, T, and V. Now the question asks you to find which particle is a negatively charged ion. Can you do it? You have to count, you have to go through the number of electrons and protons in each particle and tell me the answer. Tell me the type of the particles is P, Q, R, S, T, O, V. Wait. This one.
Done.
What is the answer?
T.
P. P O V.
T.
Or, yeah, T. Right. Why? You are having extra protons and extra
Mm.
electrons and protons. First one, second one, P, Q, R, S, equal number of protons and electrons. So those are atoms. T, you are having 18 electrons, 16 protons. So extra 2 electrons are there. And V has less electrons than protons. So it's a positive charge. So the answer should be V. Then, which particles are atoms of metals? So for that one, you need to know the periodic table as well. For the moment, just skip that part. Mm, right. So the next one is atomic number and the mass number. What do you know about atomic number and mass number? Have you studied about this? Oh no.
No.
Anyhow, you'll study these things in the third lesson, third subtopic. Atomic number is the number of protons or number of electrons. I told you when you take an atom, you are having equal number of protons and equal number of electrons, no? So proton atomic number also known as the proton number. That means that is a number of protons. But when you take an atom, those proton number is equal to the number of electrons. So we can define atomic number either as the number of electrons or number of protons in an atom. Right? So atomic number is the number of electrons or protons. This is also known as a proton number. Atomic number, also known as the proton number. The number, can't say that. So you can see this no. Number of protons in an atom or number of electrons in a neutral atom. Neutral atom means there's no any charge. If there's a charge, you can't say that those two are equal. So if it is a neutral atom, there's no charge, so you have equal number of electrons and protons. Example, the carbon. In that diagram, can you remember how many electrons were there? In that diagram where the electrons are moving around the nucleus?
6.
6. So atomic number of the carbon is atomic number of carbon is 6. Right? Because in carbon, there were 6 protons. 1, 2, 3, 4, 5, 6. 6 protons. And there were 6 electrons as well, but I'm drawing only protons and electrons. Here there were 2 electrons, here 4. In red color, I'm drawing neutrons. You should have 6 neutrons as well. That is the composition of the nucleus of carbon. So, but the number of nucleus doesn't affect the atomic number. Remember that atomic number is totally dependent on the number of protons. Nucleus has 6 protons and 6 neutrons. There are 6 electrons. Six electrons moving around the nucleus. Finish?
Done, teacher. Yeah.
Okay. Next, mass number. Mass number means the number of protons and number of neutrons. Number of protons plus number of neutrons. Mass number right? That is the number of protons and neutrons in the nucleus of an atom. of an atom. When you take carbon, I told you in the nucleus you are having 6 protons and 6 neutrons. Then tell me what is the mass number?
12.
12, yes. So the mass number is 12. That is the way to calculate those mass numbers and atomic numbers. So mass number is equal to number of protons plus number of neutrons. Mass number. So the mass number of carbon is carbon is 6 plus 6. That means 12. Quickly write this. And then I'll give you another question from a past paper.
Done.
Mm. Then, right, we'll do the isotopes as well. Then we can do this question. What are isotopes? Isotopes are the atoms of the same element which has equal atomic number but different mass numbers. Now, when you take carbon, basically there are 2 isotopes, right? It's like this. Isotopes. Atoms of the same element with equal number of protons but different number of, or equal atomic number but different mass numbers. You can define isotope in different ways, in 2 different methods. One is atoms of same atoms of same element with equal atomic number but different mass numbers. Different mass numbers. Equal atomic number but different mass numbers mean what? This is also defined as atoms of same element with equal proton number but different mass numbers. Equal proton number but different neutron numbers. How does this become the definition which is equal to this definition? Now here look at this. When you take carbon, there are two isotopes. Usually when you take an element, mass number is given in the left hand side, superscripted on the left hand side, this side. Okay, so we write the mass number here. Mass number of the carbon, I'm writing it as 12 because we calculated that you had 6 neutrons and 6 protons in the nucleus of carbon. So it was 12. 6 plus 6, I told you the mass number is 12. And the atomic number is given subscripted in the left hand side like this. C12. 12 mean the mass number, 6 mean the atomic number. This is the mass number. This is the atomic number. So carbon can also be available as C13, but their relative abundance is very less. That means when you take right, majority of these carbon atoms are C12 carbons, and like very few percentage will be C13. So that's why we call C13 has lower relative abundance. Abundant, most abundant carbon is this C12 one. So those two we are called the isotopes because they have equal number of protons. Here this is also 6. So they have equal number of protons but different mass numbers. Now let's count the number of electrons and protons here. Electrons, protons and neutrons here. Number of protons in this carbon isotope. Those two are two isotopes of carbon. I told you atoms of same element. So element is carbon. Those are two different atoms. Can you understand that? Right. So can you tell me the number of protons in this isotope?
18.
No. Proton
6.
6.
Yes.
Atomic
Right.
number is equal to
6.
right. Proton is 6. Then number of electrons
Also 6.
also 6. Number of neutrons
Also 6.
also 6. Why? To count the number of neutrons, you have to look at this mass number. Atomic number means the number of protons. You have to deduct atomic number from the mass number, then you will get the number of neutrons.
Yeah.
Now, let's go for this isotope. How many protons are there in here? How many protons?
6.
6. Yes. How many electrons?
6.
Again 6. How many neutrons? Mass number minus atomic number. Mass number minus atomic number. How many
3.
neutrons? Huh? Here 13.
1.
Here 13. Here 6. Mass number is 13. Atomic number is 6. What is mass number? Mass number means number of protons plus neutrons. Atomic number means number of protons. Now I am asking what is the number of neutrons? How can you calculate? How can you calculate?
13 minus 8. 13
13
minus
minus 6.
6. 5.
Because now here proton plus neutron. Here only proton.
So
Now I
7.
need neutrons.
So
7.
7.
Yes, it's 7. So the number of neutrons are 7. Now you can see the number of protons in isotopes. Protons and electrons are same. That's why they have the same equal atomic number. But the number of neutrons are different. Yeah, same element with equal proton number but different neutron numbers. As they have different neutron numbers, they have different mass numbers as well. Can you understand that?
Yeah.
Okay. So can you quickly write this? Anyhow, I'll do this one in theory class as well. This will be the third subtopic. That means you will be able to do this one in third class maybe, yeah. Not next week, week after the next week.
Finish, teacher.
Okay, right. Then we have to do some questions. We'll do one question. This one. Fill the number of protons, neutrons, and electrons in chlorine 35 and 37. Chlorine has two isotopes, chlorine 35 and 37. Fill the table. You can see the screen, right? Okay.
Done.
Number of protons in chlorine, 35. How many protons are there?
17.
17, yes. Okay, the atomic number was given as 17. I don't know whether you could see that. Okay. Now, number of neutrons?
18.
18. How did you get it? 35. Yes.
17.
All right. Number of electrons?
17.
70. Then chlorine, 37. Number of protons?
17.
17. Number of electrons?
20.
Electrons?
Electrons, 17.
And 17. Number of
Oh,
neutrons?
20.
20. Okay.
Oh,
Did you understand this?
yeah.
Okay. Now you know what is an atom. What are the three subatomic particles? What is mass number? And the isotopes. Okay. So you covered a lot of things in today's class, and I think now you can score around 5-6 marks from the paper, right? We have to do some calculations in isotopes. I'll add those questions once we complete the theory part at our class. Okay. So keep that in your mind. So the link will be given for your LMS from next week onwards, and you will have the class from 6 to 8. Okay. So for today, shall we stop then?
Yeah.
Okay. So make sure to go through our previous video, I mean the yesterday's video, and hope you'll join from the next week for the grade 9 class, right?
Yeah.
So can you understand what I did today? Do you have
Yeah.
to clarify? No.
Yeah. Yeah.
Okay, okay. Right. So shall we stop?
Yeah.
Okay. Thank you for joining.
Thank you, teacher. Thank you,
Bye.
teacher.
God bless you.